Hello everyone, it's me Arvind catching you on another Math Tutor Edu's lecture video. Okay, in this lecture video, I'm going to discuss a new subtopic within the chapter differentiation, which is the application of differentiation. Okay, before this, we have discussed the concepts and the formulas of the differentiation, and now we are going to apply it through the application of differentiation, guys. Okay, so there are a total of 5 applications, okay, which you're going to learn. But then I decided to break into the 5 segments for your convenience. So in this video, I'm going to cover the part 1. Okay, so let me just discuss the part 1 for you. So the first one will be the equation of tangent and normal to a curve. Okay, so in order for me to explain this concept to you, okay, let me draw you a simple graph image. So from there I can explain easier. So let's say, okay, this is your graph. Okay, let me sketch a graph. Okay, you have a y-axis, you have an x-axis, and here is your origin. Okay, so let me just draw a curve graph. Okay, so from here, let's say you name this curve graph as fx. So from here, your y will be equals to fx. Okay, so let me just move this over here. Okay, and then since it's involving tangent and normal, okay, tangent to the curve. So tangent to the curve means it must touch only one point at the curve and it must be a straight line. Okay, that's how a tangent is. So from here, okay, let me just draw a tangent line to the curve. Okay, try my best to get as accurate as possible. Yeah guys, second try. Okay, okay, is this close enough? Okay, final take 3. Please make this work. Okay, okay, acceptable. All right, so this is your tangent. Okay, this is the straight line which is tangent to the curve, which touches only one point at a time. Okay, and from here, let me draw a normal line. Okay, which means that line is perpendicular to the tangent line. Okay, so let me just draw a 90 degree. Okay, and this one will be a normal. Okay, so how are you going to relate this equation of tangent and normal to a curve? Okay, in order for me to explain this, okay, let me show you a simple example. Okay, so example 1. So let me draw a straight line. Let me read the question for you, okay, which will be appeared in the image shortly. Okay, find the gradient of the curve y equals to, in a bracket, 3x minus 1, close bracket, and then times with x minus 1 at the point whose x coordinate is 1/2. Okay, so this is the question. Okay, so I hope you have seen the question. Okay, if you think you don't know how to do, okay, don't worry, I'm going to teach you now. Okay, this one is basically a lecture video, guys. Okay, we are learning a first concept, so let me teach you how to encounter this type of question. Okay, so here you have the equation y, okay, in a bracket, 3x minus 1, okay, close bracket, x minus 1. Okay, so to proceed, what we're going to do is we're going to expand this bracket. Okay, so 3x times with x you get is 3x squared. So 3x times with negative excuse me, 3x times with negative 1, you get is negative 3x. So negative 1 times with x, you get is negative x. Negative 1 times with negative 1, you get is positive 1. So negative 3x minus x, so this one will be negative 4x. Okay, so this one is considered to be the first step, guys. Okay, so once you already done this, okay, the next step what we're going to do is we're going to find the differentiation. Okay, why are we going to find the differentiation? Okay, remember guys, in the question they mentioned gradient of the curve. Okay, so if the question asks you to find the gradient of the curve, okay, that means they're referring to the gradient of the tangent. Okay, gradient of the curve is also referring to the gradient of tangent. Okay, just want to clarify this to you. Okay, so in order to find the gradient of the curve, what you need to do, you need to perform the differentiation, which is dy over dx. Okay, so from here when you differentiate this, okay, so 2 times with 3 and then the power you minus with 1, so from here you get is 6x. Okay, minus 4x, you differentiate this, you get is minus 4. Okay, the constant will become 0. Okay, so from here the question is already given to us is our x coordinate is 1 over 2. Okay, so what you're going to do is we're going to substitute the 1 over 2 over here. So when x is equals to 1 over 2, okay, so this 1 over 2 we are going to substitute into this dy over dx equation. Okay, so from here your dy over dx will be equals to 6 in a bracket, okay, which is times with 1 over 2 minus with 4. Okay, so from here your 6 will get simplified, become 3. Okay, the 2 will get simplified, get 1. Okay, so you only left with 3 minus 4. 3 minus 4 is negative 1. So from here your dy over dx, or in this case gradient of the curve, is equals to negative 1. Okay, they just ask us to find the gradient of the curve, so you can just leave your answer in this way. Okay, I'm repeating this again guys. If the question asks you to find gradient of the curve or gradient of the tangent, that means you need to perform the differentiation. Okay, so let me just underline this solution. Okay, it's a kickstart. Okay, very simple example to just give you an overall idea on how this question is going to be. Okay, so we have done with the example 1. Okay, let us go with another one more example. Okay, example 2. Okay, so please wait guys. So let me read the example 2 now. Okay, the question is going to appear on the screen, so you can read it over there. Okay, find the coordinates of the point on the curve y equals to 3x squared plus 2x plus 1 such that the tangent at the point is perpendicular to the straight line 8y equals to negative x plus 11. Okay, so now it's going to be a little bit complicated, but don't worry, we can still solve it. Okay, so from here, in order for us to approach this question, we're going to approach with the curved line first, and then we're going to with the straight line, okay, which is the normal line. Okay, so let us proceed to do our working. Okay, let us begin with the curve. Or if you have no idea on how to approach this question, okay, I will advise my students to sketch the diagram. Okay, so just let me draw a quick diagram. Okay, y, x, origin. Okay, let me just draw a curve. Okay, this is not 100% accurate guys, this is just a sketch. Okay, just want to inform this earlier. Okay, So this is your curve line. Okay, and then let me draw the tangent. Okay, so this is the tangent line. Okay, the black color is indicating the tangent, and the purple one is indicating the normal or perpendicular line. Okay, so from here, once you draw the diagram, it makes things easier. Okay, this curve line you can just write y is equals to 3x square plus 2x, okay, then plus with 1. Okay, and then for the perpendicular straight line, you can just write your equation where 8y equals to negative x plus with 11, or to make things easier, you just express in terms of y. Okay, in this case your y will be equals to negative 1 over 8x plus with 11 over 8. Okay, it's just the same. Okay, so once you do this, okay, you get the idea. You already convert the question into the sketch image form. Okay, now it will be easier for us to solve. Okay, now what we're going to do is we're going to start with the curve. Okay, so we write the equation of the curve here where y is equals to 3x square plus 2x plus 1. Okay, the first step what we need to do is we need to find the gradient of tangent. So how to find the gradient of tangent? Okay, for that what we need to do is we need to differentiate this first. Okay, that will be our very first step. Differentiate y with respect to x. So for that it will be dy over dx. So from here you differentiate y with respect to x. So from here you get is 6x plus with 2. Okay, so this is your very first step. So once you get this, so the next thing is you need to find the gradient of tangent. So how to find the gradient of tangent? The question didn't give any coordinate, so it is difficult for us to find, but the question has given us a hint. This normal line, the equation is 8y equals to negative x plus 11. When you express in terms of y, it will be equals to negative 1 over 8x plus with 11 over 8. And remember, these two are perpendicular. Okay, when it's involving perpendicular, still recall the coordinate geometry equation where m1 times with m2 equals to negative 1. That's the equation we are going to apply over here. Okay, using that equation we are going to find the gradient of tangent. Okay, so that will be our step 2. Okay, so from here, using formula m1 times with m2 equals to negative 1. Okay, this formula you learn through your coordinate geometry, guys. Okay, so just want to recall you this. So any two perpendicular lines, so their product of the gradient will be always negative 1. Okay, so let me just write over here. So m tangent, which means gradient of tangent times with gradient of normal is equals to negative 1. So gradient of tangent is the one we are going to find now. So just write here m tangent. Okay, gradient of normal we already have here, which is the negative 1 over 8. Remember, y equals to mx plus c. M is actually the gradient of the straight line. So in this case, you have your m is equals to negative 1 over 8. So you just write the negative 1 over 8 over here. Negative 1 over 8, close bracket, equals to negative 1. Okay, So using this formula, now you can find the gradient of tangent. So in this case, your gradient of tangent is equals to 8. This black color line is having the tangent, the gradient of tangent 8. Okay, so this is your step number 2. Step number 1 clear, step number 2 clear. Once you identify this, what you do, you substitute this 8 into this dy over dx. Okay, so when dy over dx equals to 8, so from here 6x plus 2 is equals to 8. So this 2 from the left hand side, you move it over to the right hand side, it will be minus 2. So 8 minus 2, it will be 6. So from here 6x will be equals to 6. So from here you get your x equals to 1. Okay. So this is your third step. Okay, once you already find the x value, the next thing what you need to do is, using this x value, you need to substitute into the y equation. Okay, you don't substitute into dy over dx again, guys. You have to substitute into the y because you need to get the coordinate. Okay, so we are requiring to find the coordinate. So there is a difference between y and dy over dx, guys. Okay, dy over dx is the gradient of the curve. Y is the curve itself, the equation of the curve itself. Okay, I just want to clarify you this. When x is equals to 1, okay, so you substitute this into the y. So from here y is equals to 3 in a bracket 1 square plus 2 in a bracket 1 plus with 1. Okay, so you substitute the x into the y equation. So from here 3 plus 2 plus 1. So from here you get your y is equals to 6. Okay. So your final answer you can write in the coordinate form, which is 1, 6. So this is your final answer. Okay, so let me scroll this up. Alright, we have come to the end of the lecture video for today. So I hope you understand the part 1 of the application of differentiation concept. If you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming AdMaths lecture videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.